Let's look at type of transformer. So we're going to draw this type of transformer here and explain it a little bit. So as you can see, already started with the center tap transformer. Center tap transformer has a site of two secondary windings and with the same number of turns. So they are 50% tapping. So a center tap transformer is like this in a primary site. This is the primary site, and in the secondary site the center tap transformer is like this. Is the equal amount of voltage. One, two, three, four. One, two, three, four. So we have S1 and S2, which is the secondary part of and other one. So there's a voltage number 1 and voltage number 2, and these voltage are equal. V1 it's equals to V2 because these windings are equal. So N1 of the secondary side, let me say they are equal. Here's a equal voltage but on the secondary side. So this is how the center tap transformer is like. Let's check the other ones. Let's check at this step up and the step up transformer and the step down transformer. So a step up transformer has a less winding in the primary side and more winding in the secondary side. This is to step up the voltage. So they use a step up to step up the voltage. So that the current can travel and there is less current on the electrical cable. So we have the voltage of the primary side is less than the voltage on the secondary side. The current on the primary side is greater than the current on the secondary. The number of winding on the primary side is less than the number of winding in the secondary side. So for the step down it's vice versa. You have more winding on the primary side. So that means there's a more current. So this one is to save a cable. So if you have more current on the secondary side, you'll use a bigger cable because the current the current determine the cable size. The greater the the current, the greater the size of the cable. And if you put it on the in the street, or it can be dangerous, so it can cause more material as well, more material for this one if the current is great. So if it's less, it's easy to transport the voltage or the current to the other side. So this one is a step down transformer. The current, the voltage in the primary side, it's greater than the voltage in the secondary side. The current in the primary side is less than the current in the secondary side, and the number of winding in the primary side is greater than the number of winding in the secondary side. So this is how we can explain some of them. Let's check other transformers. So we have an isolation transformer and a multi-winding transformer. So a multi-winding transformer has a lot of winding in the secondary side. So we have, let's start with the multi-winding. The multi-winding is a lot of multi-winding transformer. So you have a primary side and a secondary side, which there are 3 or more. So they have different winding. So the voltage here in one is not equals to the voltage in the, like voltage here, and the voltage here, they're not the same. Same apply to the current, they are not equal. So the current not equal, and the number of turns, I'm checking on the secondary side, they are not equal in the secondary side. So this is how a multi-winding transformer, isolation transformer, has the same value, it does not change. P Vp equals to Vs. NP equals to NS. The current, they are all the same. So unlike here, I was checking on the secondary side. Here I'm checking both sides. They are equal. So that's it for type of transformer, and if you want more video like this, you can just subscribe or visit to the address above. Thank you for watching, and see you on the next video.